Today we're exploring the Proto49 Mini Wood Lathe. Well, welcome back to the mini workbench. On the workbench today we have a mini wood lathe that I built a little while ago. This little guy was built for a particular purpose, and in fact after that was achieved, it's been rebuilt considerably. So the first iteration, let me take this off before it falls off. The first iteration was that this was powered by an electric drill. You can see the artifact there. So the drill was mounted in that section there, and basically the chuck of the drill protruded through here, and in the chuck I would have the drive spindle, the drive burr, which would go into the chuck, and that would press into the end of the piece of wood, and the original headstock, which was all thread, would screw up onto it and jam it in there, and there was a friction fit onto the tailstock. Now that was all well and good until I repowered it. The first problem I had was that the chuck wasn't very sound. It had some play in it, which ended up in being play in the job. And when you had the chisel working away, or the tool working away, there would be too much chatter and it would bounce around. So it wasn't very satisfactory. So I decided to replace the drill with a fixed shaft, and inside here we have a shaft similar to this one. This was the original shaft. I think this was made from a bolt, but this one's actually a ground shaft to the right dimension for the inside, the 10mm dimension for the inside of the bearings. But there's a little step on the end here because there's an 8mm thrust bearing on the end, followed by a bearing here, through bearing, and another bearing race here. So we've got two bearings plus the thrust bearing in the shaft mechanism. So that makes that quite strong, very stable, very free running. The tailstock, this is the second tailstock that this has had. The first tailstock was mounted in exactly the same way, a pin into these fixed position holes, and then those holes had a bolt coming up through. And that worked quite well. I've got some length variation here. There's a whole inch here, and so I've got, maybe it's less than an inch between those holes, but I can move this to the position that I want for the piece of timber that I want in there. This is okay, but I think I'm going to modify this and have that on a slot, and have a hole that's actually a slotted hole, so I can do it sliding all the way through. And in fact, that's what this component is the start of. That's the locking nut from underneath. I need to probably shorten that to make that equal distance, but I've welded that. I actually since realised that it's actually a bit short because I didn't measure it properly, so we've got to deal with that issue. And here is just made this today. This is the mounting that goes up through the dog holes in the mini workbench, and then mounts into that thread, screws in through the centre hole here, so that mounts it securely to the bench. So the motor here is a sewing machine motor. That's a 180 watt sewing machine motor. It runs very fast. It's up to 10,000 revs. You can't run it flat out. So I've got a little fan controller that plugs into the normal sewing machine control here and gives me a switch and a fan control. There's a bit of reduction here. I think it's, I can't remember what the reduction was, but it still runs, quite fast, maybe 4,000 revs here when it's flat out. So you have to actually speed control it down, which takes away the torque. Yeah, it's not quite right. I've got an alternate motor that I might use on that, and we'll explore that in another video. But essentially this is an introduction to the latest and greatest technology for mini woodworking lathes from the Proto49 workshop. And as I do the modifications, I'll record them, and we'll see if we can get a couple of videos out to show this improvements on this prototype as we go. Well, I'm at a bit of a crossroads when it comes to this this guy. One of the possibilities of repowering it is to use a washing machine motor, quite large, but I've got a 1-to-1, and that'll be a 1440 revs per minute. So I've just turned up this this V-belt pulley, and that's sitting in there nicely. V-belt's right down to that surface. It's sitting on there flat, it's not angled one way or the other, so I've got the V correct, and the depth, it's not the bottom of the teeth is not touching the bottom, so that's sitting nicely in there. So that's done. I'll just turn that back around the other way. So I can't get in there because that's tight, but essentially that's a nice V-belt pulley. So that I'll just spin that up for you to see how fast that runs. So I'll turn it down to its lowest. It starts quicker because of this particular fan supply. It's relying on a heavier load than this motor, but it slows down. Just that capacitive start. If I turn the throttle up, this can go very fast. We don't run it that fast when we're doing our cutting. These are my cheap chisels, which I got for almost nothing. Single figure dollars. So I have to run it fairly fast to get a nice cut, but I'm not going to cut anything. I'm not going to cut anything off there. Turn that off. I'm not going to cut anything off there because that's perfect, so I don't need to touch it. But this is essentially the way it works. I'm sitting in there. I've got the lights on. Actually, another light makes it easier. And I've just finished off those surfaces. Alright, so the problem is, what I am noticing, and I'll disconnect the power, get rid of our power system. What I am noticing, let's take the belt off, is this shaft, whilst running freely, really nicely on those bearings, is starting to chatter. I've got that much movement. And that's a bit annoying actually. Part of that is the shaft and the inside diameter of the bearing not being exactly perfect. But I've also got a bit of other noise, and I think it's the thrust bearing that I've got at the back. When I push on there, I can hear that, so that might be a bit dry. Now I've got to cast my mind back when I put this together last time, after assembling it after painting. I may not have put a little dob of grease on there, which I was intending to do. So with that issue, chatter issue, it's got me questioning whether or not this is actually going to be successful in the long run, this whole experimental lathe. I'll just take that off there. This faceplate was just a nut that I welded onto a washer. And put some holes in, and that's actually worked beautifully in this sort of application. I had to re-drill the holes on the other side because I didn't quite get it centered. But this is fantastic, and it's created a really nice V-belt pulley, and perfectly sturdy. With a 10mm or just under 10mm hole through there, I can push it onto here, and I'll drill a hole down through here and put in a grub screw, and I'll also make a flat, if not drill a hole in the actual shaft itself, which is what one of these grub screws here does drop into a small hole. In fact, there's no grub screw in there. That's interesting. So that grub screw exists, but I can't see that other grub screw. So I don't know whether that's fallen out or what's going on there, or whether I didn't put it on in the first place. That's always a possibility. So it's got me questioning whether I start again the whole machine. I'm going to be remotoring, rethink about repowering, rethink about how do I get rid of this little bit of chatter. I was going to do some work on here to make this a slide. There's actually a lot of work on tuning this when it may not be worthwhile at all. So I'll just take that off. It doesn't go back on perfectly. It's exactly the same. So that's another little challenge with the way I'm approaching this. So not sure. At a bit of a crossroads as to what to do next with the sewing machine powered, super high speed sewing machine powered mini woodworking lathe. Well, thanks for watching on this short video introducing the Proto49 Mini Workshop Mini Woodworking Lathe.